Okay, number 12, each table contains some points on a graph. Circle yes or no if the table could be a function. We don't know for sure because this only shows a little part of it, but what we're going to do is basically look back. This is a table view of what we did in problem 1, which is looking to see is there anywhere that the input has two outputs. So first we're going to look, is there any x that's repeated? So let's look at A, 0, 1, 2, 3, 4. There's no x's that are repeated. So that definitely could be a function, yes. Right? First we're looking to see if they're repeated. It doesn't matter. It's okay if the y's are repeating, 5, 5, 5, 5, 5, right? This actually would be a graph that would look like this. If that's my coordinates, this one would actually go 1, 2, 3. Oops, no, let's mess that up. This would actually go like this, right across at 5. That's a function. That's nowhere that the points are on top of each other. So that's okay. So let's look at part B. 0, 1, 2, 3, 4. Again, they're not repeating, so it's okay. That's good. Doesn't matter what the y's are doing if the x's are not repeating. So C, let's look at part C. 0, 3, 4, 3, and 2. So right here, I have two different inputs of 3. So what I need to look and see is, are the outputs okay? So here the output is 3, here the output is 3. They're exactly the same. That's what I want, right? Every input should have one output. If I put in a 3, I get out a 3. Later, I put in a 3, I got out a 3. That's good. So that's a good thing. So C would be yes. And now I want to look on part D. So 0, 1, 1, 2, and 3. So again, here and here, I have two inputs that are the same. So I come along at one point, I put a 1 into my equation, and I got out a 4. And then I came back later, I put in a 1, and I got out a 5. That's not good, right? If I have an equation and I plug in a 1, I should get the same thing out every time. So that is not a function, right? It's not working properly. Okay, 13. John starts saving for a car with $600, and each month he adds 200 to the amount. So John's amount Y in any month X is equal to his total amount saved. So circle the quadrants from the list that would allow you to create a graph of his balance. So basically what this is telling me is, I could write an equation, though I don't really have to, right? So it's $200 times the number of months plus the 600 he started with. But if I think about, right, X is the months and Y is the amount of money that he has, he's never going to save. He's never going to have negative months or negative dollars, right? So he's never going to be over here where the months are negative, right? This would be like -1 month, -2 months, right? He's never going to have those. And he's never going to be down here with negative dollars, right? Over here, this quadrant is positive months, but negative dollars. He's never going to have that. So he's only going to be up here, right? A lot of our real life stuff is always in that, well, sometimes it's always going to be including that top right quadrant. That's quadrant 1, right? Remember, this is quadrant 1, 2, 3, and 4. We're going to be in quadrant 1, right? Where everything's positive. Time's going forward and money is going up, right? If there is it could be, in a different problem, maybe a little different, that he's losing money, and then he'd be in quadrant 4 also, but not this one. Okay, problem 14. There are 134 students in the 5th grade. 6 students will go in a combination class and the rest will go into 4 5th grade classes. Create an equation in terms of the number of students in each class. So we know that, let's pick green here. Let's see what the variables are. Number of students is X, right? So we know that there's going to be 134 students. I know that 6 are going to be in a combination class. And I know that the other classes, there's 5, no, there's 4 5th grade classes. It's kind of confusing. So there's 4 classes with some number of students in each one. That makes sense. 134 total students. So maybe in your mind you're thinking, okay, there's 134 students, 6 of them are in a combination class. So that leaves 128. And how many are in each of the classes? Well, then I would divide by 4. All right, so that'd be 332. So that's my answer, right? This kind of is a quick way of how you would probably figure that out in your head or on paper, but this is what the actual equation would be when it asks me to write an equation. The total number of students is the kind of the extra kids, the combo kids, plus the number of classes times how many kids are in each one. So anyway, that would be my equation. So I know that, let's put it this way, 4x plus 6 equals 134. And we kind of just solved it over here the quick way, but if we did it the right way, showing our work and everything, I would subtract the 6, get 4x equals 128, and divide by 4, and the x would be 32. All right, 15, a phone company charges a rate R for each hour that Jill wants to use the phone. Write an equation that expresses the total cost for T hours. Right, so I want to know the cost is going to be the number of hours she talks on the phone multiplied by the rate. Right, so let's kind of make an equation for these things. So cost was C, number of hours was T, and the rate was R. Or remember, multiplication, the order doesn't matter. So depending on how, these are going to be multiple choice questions on the test. So you got to find the right answer. So it could, this would be a good answer, or, right, this means the exact same thing, right? T times R, R times T. So be on the lookout for things that mean the same thing as what you found, but might be represented a little bit differently. All right. All right, we got a lot of work on this thing here. So 16, the amount of water in a tank in gallons is a function of time in hours shown at the right. State if the statement is true or false. So 16a, the tank is empty in 11 hours. So let's look at what our variables are. So here, my x-axis is the time, and the y-axis is how much water is in the tank in gallons. So it looks like, before I look at any of those questions, let's look at what I have here. I have a water tank that at time 0, at the very beginning, has 100 and, these go by tens, so there's 110 gallons, my y-intercept, when the time equals 0, and then it goes down at a steady pace the whole way, and then when I get out here, it has 0 gallons, right, when the time is 10, 11, 12 hours. So that's kind of what we have. Let's see, we can figure out the slope. I bet that's going to be part of this too. Okay, the tank is empty in 11 hours. That is false, right? We just saw over here the tank is empty at 12 hours, not 11. The maximum amount of water in the tank is 11 gallons, right? I wonder if that's supposed to be at 11. I don't know. But anyway, that's false anyway, because up here, it's the maximum amount of water in the tank is 110. So I think what that's trying to get you to do is not just count the boxes. If I just counted the boxes, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you have to actually look at the scale. It's 110. So maximum is 11 gallons. That's false. The maximum amount of water in the tank is 110 gallons. That's true. We just saw that. The rate of change is the amount of water in the tank decreasing at 10 gallons per hour. So let's find a slope triangle and find out. So we have a point here. Let's pick, to make it nice and big, let's go here. Right, so over time it's going down and over. So it's going down 1, 2, 3, or actually by tens, 10, 20, 30, 40. Going down 40 every 1, 2, 3, 4, 5, 6, 7, 8. So my slope is negative 40 gallons every 8 hours, which is negative 5. It's going down 5 gallons per 1 hour. So the rate of change is 10 gallons per hour. That's false. It's 5 gallons per hour. At a time of 6 hours, there's 50 gallons in the tank. So let's see, at 6 hours right here, right, there's 50 gallons in the tank. That's true. And at 90 hours, there's 2 gallons in the tank, right? That's not true at all. I think what it's trying to get you to do is go up 90 and over 2, right? This point right here, that's the point. There's not 90 hours and 2 gallons. There's 90 gallons and 2, right? That's false. They have the units flipped. All right, 17. This will be maybe the last one for this video. For y equals 1 over 4x plus 1, state the slope and the y-intercept and graph the line. So if we can't do this by the end of Math 1, then we've got a major problem, because this is critical, critical, critical. So if I look right here, the slope is the part in front of the x, right? Y equals mx plus b. So the slope, the m, is 1 over 4. And let's do a different color here, right? The y-intercept, the b, is 1. So I can figure out what those two things are from the equation, and on the graph, I know the y-intercept, if it's 1, that means it goes there. And then the slope tells me what to do from that point or any point on my graph that I know is on the line. So I would go up 1 over 1, 2, 3, 4. Look like that. So my slope was 1 over 4, and my y-intercept was 1. Actually, I'm going to try and finish this one on the same video here, and then we'll take a break for Unit 1 and Unit 2. So 18, evaluate the following functions. So we practiced this a little bit above with the function machines. This really just means plug in, right? And what we have to understand is when I see this notation right here, f of 2, that means that the x is 2. So I'm just going to take my equation right here, and I'm going to plug in a 2. So negative 3 times 2 is negative 6, plus 1 is negative 5. So f of 2 equals negative 5. Same exact function, but now, right, we're going to just try and put something else in there. What happens if the x is negative 5? So negative 3 times x plus 1, but this time the x is negative 5. So negative times a negative is a positive. 3 times 5, 15 plus 1 is 16. So f of negative 5 equals 16. All right, b, same exact thing, but we have parentheses around the quantity 3x plus 1. So that's different, right? Because now we have to do what's inside there first. So, right, remember what this means. This means that x is 2, h of 2, right? And you can see here, this first one calls it f, then h, then g, then m. It doesn't matter. It's just a name. You could call it whatever you want. You could call it y, but it's just, you give them different letters because sometimes you graph them on the same graph and you want to put a name on them so you can see which one is which and you don't get confused. If they're all called f of x, you wouldn't know which one went with which equation. So h of 2 equals negative, right? So we're going to take our equation right? I'm going to put parentheses where the x is, and then I'm going to put in what the x is. 3 times 2 is 6 plus 1. And then in parentheses, 6 plus 1 is 7, so negative 7. H of 2 equals negative 7. So same thing, same exact equation, right? 3, I'm going to make it a little bit bigger this time, plus 1. 3, this time I'm going to plug in a negative 5. That's what I plug in. So 3 times negative 5 is negative 15. Plus 1. Negative 15 plus 1 is negative 14. Right? This negative out front, you can kind of think of it just going through, like I was taught as a kid, it goes through like a bullet and just flips all the signs. But really what this means is you have a negative 1 in front and it's being multiplied through. So negative 1 times negative 14 would be positive 14. This is H. H of negative 5. Kind of sloppy, sorry. All right, 2 more and then we're done with chapter 1 and chapter 2. So G of 7. So here my x is 7. So 6 minus x squared. Right, wherever I see the x, I'm going to put parentheses, then put in my number. So 7. So 6 minus 7 is negative 1 squared, right? So remember PEMDAS, I got to substitute in, or replace the x with what it is. Then I got to do parentheses. So that's what I did here first. So I did parentheses. Now I got to do exponents. So negative 1 squared. Negative 1 times negative 1 is positive 1. So G of 7 equals 1. And G of 5, so now I'm going to plug in a 5. 6 minus x squared. Now the x is 5. So 6 minus 5 is 1 squared, which 1 times 1 is 1. So G of 5. So you might be wondering, like, how is this possible that we got the same answer for both, right? That's going to be, well, those are the ones that are shaped like this, right? So for different x values, you're going to have this, same, you can have the same y value at 2 different x's. So that's what happens there. Right, m of x equals 6 minus x squared. So you can see this looks similar to c, but it's a little bit different. So let's see what happens here if I do 6 minus x squared. Right, so now my x is 7. 6 minus 7 times 7 is 49. This pen's not working too good right now. 6 minus 49 is negative 43, right? So remember, the trick for subtracting big numbers from little numbers is subtract the little one from the big one, but then you got to flip the sign. Okay, so last one, and then we'll break our video here. So m of x equals, m of 5, sorry, is 6 minus x squared, and I replace the x with the 5. 5 squared is 25. Right? If I don't know what 6 minus 25 is, I know 25 minus 6 is 19, right? But I have to change the sign because I flipped the order. All right, so that's how we do all of the things from chapter 1. Tons of information there, lots of solving, some things that we haven't seen in a long time, so definitely use those videos to help guide your study guide.